Hey, hello. In this short video, I'd like to focus with you on the energy transition. More precisely, I want to talk about one of the projects that we ran for an electrical grid operator. So let's talk about the electricity grid. In many places in the world, the electrical grid is several decades old. In some places, the grid can be nearly 100 years old. Now try to think back 50 or 100 years and try to imagine how people lived their lives back then and how electricity played a very different role in those days. And contrast that to today's electricity use. And think, for example, of the advent of the electric car, which causes high current loads during battery charging. Also, think of decentralized power generation via solar panels. This means that power is no longer generated centrally at a power plant. Suddenly, each house with solar panels has become its own mini power plant, something the grid was obviously never designed for. The intermittency caused by renewable energy, which is mainly caused by uncertainty we have about the weather, causes all kinds of stability problems in the grid. And grid operators want to improve their information position, to solve congestion problems, and to be able to make better investment decisions for grid reinforcement. They achieve this by measuring the state of the grid at various places, also near the consumers, near you. In other words, they would like to use data from the electricity meter in your house. Of course, the electricity company already reads out the meter for billing purposes, but this happens monthly or maybe once half a year. For the present use case, we talk about much more fine-grained measurements. Typically, there is a legal framework for the use of metering data. The Dutch energy law, for example, is very explicit about the use of metering data for grid stability control. That is, the law states that the grid operator has to, where possible, aggregate measurements from individual households on a street or neighborhood level. Although the grid operator is only interested in aggregated information about the grid and not in the usage patterns of individual households, it was previously unclear how to aggregate such metering data while protecting the privacy of individual households. And that is where Roseman Labs comes in. We have developed a solution based on multi-party computation that achieves exactly that. Namely, the grid operator obtains aggregate statistics, such as the total power consumption of a group of houses, while the usage patterns of individual households remains secret. We have built and delivered a proof of concept, and as a next step, we plan to run a pilot on a neighborhood scale. From the perspective of the MPC Alliance, I think this meter data aggregation use case and the deployment of MPC on edge devices serves as a concrete example in the intersection of privacy technology and the Internet of Things. Thank you.
Wow, I knew that session was going to be a bit intense, but hopefully you also found it to be informative. I encourage you to visit the sponsor booths to learn more about those applications and many more. We're going to take a short break,